for Miss Stewart. That was awesome. Great job teaching us about the concept of density. You guys are going to learn today how to calculate density. So just a reminder, what is density? Density is the amount of mass in the volume of an object. So how much matter is packed into space, like those examples that Miss Stewart showed y'all. Now to find an object's density, we are going to find its mass and then we are going to find its volume. Once we have those two things, we can combine them to calculate density using this formula. D equals m divided by v. This is my little trick that I use to remember the formula. When I'm solving for density, I know that it is a heart split in two. So it looks like an m on top and a v on the bottom. That's the formula for density. So let's do some practice problems just to see. We have two tissue boxes here that Miss Stewart showed y'all earlier. One of them is going to be more dense than the other because one is packed with more matter and one is empty, so tissues and no tissues. The first problem we're going to solve is with the blue box, and so we already took the measurements of this. Because it's a regular solid, we use the length times width times height to determine our volume, and that is 22.5 centimeters multiplied by 12 centimeters multiplied by 7 centimeters. So you're going to use your centimeter ruler, measure your sides, multiply them together like we did the other day, and that is how you're going to find the volume. Volume is 1,890 cubic centimeters. Remember, we use cubic centimeters because we multiply centimeters times centimeters times centimeters. Okay, now that we have our volume, we're able to find the mass. And so we would use a triple beam balance for this. Miss Stewart has already weighed this out for us, has already measured the mass for us. And so it's going to be 185 grams. Now that we have a mass and a volume, we can solve for density. So we know our formula, D equals m divided by v. We're solving for density. Our mass is 185 grams, so 185 goes on top, and that's grams. And then 1,890 cubic centimeters goes on the bottom. Then when we plug that in to our calculators, we're going to get 0.10. And does anyone know the units that we're going to write?
I do.
What is it, Miss Stewart?
Grams per cubic centimeters.
Per cubic centimeter. We can't just write grams and we can't just write cubic centimeters because we divided those two by each other. So think of the per as the little division sign. Grams per cubic centimeter. Whatever you're dividing, you need to bring those units over. So that's our first example. Don't worry, y'all are going to get tons more practice with this. Let's try another one. Okay, purple tissue box. Now, I have a feeling this one's going to be less dense, but we always want to actually calculate and not just do it based on how we think it feels. So, again, Miss Stewart with the measurements, she already has those done for us. She rocks. We are going to solve just like we did the other problem. So, does anyone know what the first step is?
We got the numbers already. I know we're gonna multiply,
yes,
right? Okay.
We're gonna multiply. So we have a regular solid, it's a box. We use, I don't know why I did this. This is more like a circle. So it's a box, so we can measure the length, the width, and the height. And so that's what we did here. We have 24 centimeters for height, 12 centimeters for width, 7 centimeters for height. Did I say height twice?
I think you did. The length is 24. We got it.
Okay, we're moving on. All right, so we have length and width and height, 24 times 12 times 7. The volume of the purple tissue box is 2,016 cubic centimeters. When we put this box on the triple beam balance, we found the mass to be 48 grams. So again, we have our formula, D equals m divided by v. We are going to plug in our numbers. Density equals 48 grams divided by 2,016 cubic centimeters. When we plug that into our calculator, we find the answer to be 0.02. And what are my units going to be?
grams per cubic centimeters. That's
Good
it.
job. Good job.
Thanks.
Again, we divided grams by cubic centimeters. So, I think we're ready for some practice problems. Let's
So,
see.
which one is more dense? Which one's less dense? More dense is 0.10, because that's like 10 out of 100, compared to 0.02, which is at like 2 out of 100. So 2 cents compared to 10 cents. And what, Mr. Hodgson, why is that one less dense? Because it has less what?
Mass.
Okay, less mass.
Matter packed into the same amount of space.
Cool. Very good.
Thanks, guys.
Yay!